working as an assistant professor in St. Joseph Institute of Technology, Chennai, Department of Computer Science Engineering. Today I am going to take topic on Wumpus world, which comes under artificial intelligence. So, the topic is Wumpus world. This Wumpus world is an artificial intelligence problem. This is a knowledge-based problem. So, using this Wumpus world, we can find what are the different facts we can move and get the goal. So, here in this Wumpus world, we have 4x4 grid. So, we are going to draw a 4x4 grid. This is the 4x4 grid. And inside, we have an agent. We have an agent inside the grid, and we have one Wumpus inside the grid. So this is the problem, right? So here inside it, whenever we are taking any problem, we have to describe the PEAS. So PEAS description should be compulsory. What is PEAS description is, on the problem, what is the performance measure? What is the performance measure, and what is the environment we are working on, and what is the actuator, and what are the sensors we are using to reach the goal. So these are all four things we have to describe to reach the goal. So initially we will see what is the environment. So in this problem, what is the environment we are going to see. So here in this environment, initially what are there in this grid? We are having a agent and we are having a Wumpus in it. So here the Wumpus action is, whenever the Wumpus sees anyone in its grid, anyone in its room, it will eat away. So if the agent moves towards the inside the room of the Wumpus will eat away. So next thing is, the Wumpus has the agent has an arrow. The agent has an arrow in his hand. Its action is to shot the Wumpus. So it takes only one action. The agent has only one time of chance to shoot the Wumpus. And one more thing is, there is a pit. There will be a pit inside. There will be a pit inside any one of the block. So adjacent to the pit, there will be a sensor called as a breeze. There will be a breeze. Okay. So 90 degrees to the pit will have a breeze. So whenever the agent moves forward, and moves into the room of the pit, the agent will fall and the game will be over. So for that, the agent has to get a prediction whether there is a pit adjacent to the grid or not. For that only, initially 90 degrees of its angle, the agent will have the breeze smell. So one more thing is, in this grid there will be also a stench, that is a smell. There will be a stench smell. So when will the agent, if the agent feels the stench smell, it means that there is a Wumpus adjacent to its stench. So for suppose if the Wumpus is in this grid, 90 degrees of its grid, that is here or here, to its adjacent, there will be a smell. Even if the agent comes here, there will be a smell indicating that there is a Wumpus adjacent to its grid. So, and then there will be a glitter. Glitter is nothing but gold. So the main goal of this problem is agent should collect the gold without getting inside the room of the Wumpus. The agent has to collect the gold. So agent has to move each grid in the form of a prediction without going into the room of the Wumpus and collect the glitter, that is collect the gold and get back to its original position. So these are all the possible ways. These are all the environment which is in the Wumpus world, that is one in 4x4 matrix. And the main goal of this problem is to collect the gold. Here this is, we are done with the environment. So this is the whole environment in the Wumpus world. Then next again, here what is the performance measure? Performance measure in the Wumpus world. The performance measure is plus 100, we are giving 1000 we are giving when the agent collects the gold. When the agent collects the gold, we are giving plus 100. Sorry, plus 1000. Minus 1000 is if the agent is being shot by the, if the agent is being caught by the Wumpus, we get 1000 minus 1000, right? And then minus 1 for each step forward. If the agent steps forward into the one grid, that gives minus 1. So it will be incremented, minus 1 like that. So when for each move we give minus 1 and minus 10 if the agent uses his only one arrow. It has only one arrow. If he uses that, it will give minus 10. So these are all the performance measure we are going to do in the Wumpus world problem. Next is, what are the actuators? What is the action the agent going to do in the grid? In the room, what are the actions, actuators we will use in this problem? So in this problem, the actuators we use, the agent can move to its left, to its right, to its up and down only of 90 degrees. Left, it can move right, it can move up, it can move down of 90 degrees only. Okay, 90 degrees it can move. And the next action is what? To grab the gold. So the next action is grabbing. So grabbing will be the next action. And then grab paniyacha. Then we have completed with grab. And then the next action is shooting. Shooting is nothing but to kill the Wumpus, we use shooting. So we use a arrow there. So these are all the actuators we are using here. The actuators are left, right, up, down of 90 degrees. Grabbing and shooting will be the actuators. Next is, what are the sensors which is used in this Wumpus world is, the sensors are, the first sensor is breeze. Breeze is nothing but to predict there is a pit adjacent to the breeze. If there is a breeze here, there will be a prediction that there will be a pit here or else here also. Okay, this is a vice versa. If there is a pit here, there is a chance of breeze here in this grid or in this grid. That is the sensor we use here. That is breeze sensor. The next sensor is stench. That is smelly. Stench is to the agent will sense that there is a Wumpus adjacent to its grid. So if the agent comes here and if he is feeling the stench smell, then there is a possibility of Wumpus in this grid or in this grid. Wumpus in this grid or in this grid. Right. So there will be only 90 degrees only. To its adjacent only it can predict whether there is a Wumpus or not. So that is, with that we are using this stench sensor. Smelly sensors. Then breeze stench is over. Then glitter sensor. So as I have said, why the glitter sensor is used to, if there is a glittering in one of the grid, there is a glitter in one of the grids, it indicates that there is a gold inside the grid. So the agent will directly go collect the gold and come backward of this same path. Okay, from where it is starting, it is moving safe to reach the gold and it will come back to its original position. That is glitter. Next is what? Bump. This bump sensor is nothing but if the agent moves inside the grid, it will touch if the agent touches the walls, there will be a sensor like there is an agent inside the grid. So we will find a bump sensor here. The next sensor is scream. Scream we use like whenever the agent uses his arrow to shot the Wumpus, there will be a scream sound inside the whole room. So the whole grid can hear the scream sound. It means that the Wumpus has dead. The Wumpus is dead and there will be a screamy sound there. Right. So these are all the actuators. This is a PEAS description for Wumpus world. That is performance, environment, actuators and sensor. Now we will go into an example. So I put a grid here now. Okay. I'll put a 4x4 grid here. So there is an agent here, right? And there is a breeze here. Here also breeze, and here breeze. So if there is an adjacent breeze here, there is a possibility of pit here, right? There is a pit here. Now here there is a stench smell. Then there will be a wumpus here, right? And there is a glitter also here. We have a gold here as well. We have a pit here with a breeze smell here and a breeze here. Now my goal is the agent has to reach the goal without reaching this wumpus. It should not reach to the wumpus and get die. It has to reach to the gold and get back to its original position. So if he is going to get back to its original position, what we are going to do is, initially this is the grid, this is the agent. He is going to step, initially the agent is in 1, 1, right? Here there is no perception, there is no any sensor in this grid. So the agent is safe here and he is visited here. So denote with V here, right? We are denoting this with a V. So the agent is safe, there is no perception for him, like there is no breeze here as well as stench here. The agent is safe. Now what the agent is going to do is, the agent is going to move to its right. If the agent is going to move to its right, if the agent is going to move to its right, the agent is going to move here. Okay, this is already visited. 1, 1 is also already visited. The agent is in 1, 2 and there is a breeze here, right? There is a breeze here and the agent is here. Okay, now there is also a stench smell here. Okay, and there is a pit here. So here, if the agent is here and agent is feeling a breeze smell, then there is a prediction that there is a pit to its adjacent. If he is feeling a breeze here, means there is a pit adjacent to its grid. So there is a possibility of grid here as well as here. So there is a possibility of breeze here or as well as here. Now the agent, what does it do is, so if he is going to take a step forward or upward, he will surely, there is a prediction that there will be a knowledge that he will surely fall down somewhere. So what is going to do is going to take back, reverse back. But this grid is visited, put as V here. This grid is already visited. So next step, what we are going to do is, the agent is going to move for 2, 1. So here, now the agent, what he is going to do is, he is going to move here upward. The agent is going to move upward and he is going to sit in 2, 1 here. Here 1, 1 already visited, 1, 2 visited, and he is in 2, 1 now. There is a gold here. Okay, there is a gold here and he has to grab the gold. Now he is already visited here, right? Now what he is going to do is, he is in this position and he, like here in this position there is a stench smell. In the example there is a stench smell here. He feels a smelly sensor here. So the prediction is there can be a wumpus. There can be a wumpus in which cell? In 3, 1 or in 2, 2. There will be a wumpus in 3, 1 or in 2, 2. But before itself, the agent has a knowledge that there can be a pit here in 2, 2. There can be a pit in 2, 2. The agent has a prediction. So what does it mean? If there is a pit here, there can be a if suppose if there is a pit here, what will be there in 2, 1 to its adjacent to pit? So there should be a breeze here. If there is a breeze here in this example, there is no breeze here in this example. Then surely there is no pit beside 2, 2. So the agent has a confidence that there is no pit here in 2, 2 and he will move forward for 2, 2. And we have to put this cell 2, 1 as visited, and he is moving confidently that there is no pit beside 2, 2 is moving forward. Now, so agent now where he is. So here in 1, 1 visited, 1, 2 also visited, right, and 2, 1 the agent visited, right, and then he is going to 2, 2, right. The agent is here now. The agent is here now. Now, what the agent does is the agent can move here for the up, or he can move for a right. Right. The agent has two possibilities. The agent can move to its right, or the agent can move to its left, up. So if suppose the agent is moving here to 2, 3, he has a sensor here. The agent has a sensor of what? The agent has a sensor of breeze. If he has his agent has a sensor of breezes, then there is a possibility of having a pit here or here, right. If an agent moves from here to here, if the agent moves from 2, 2 to 2, 3, if the agent is in 2, 3, there is a possibility of pit here in up or to its right. Then what does the agent do? It will come back, it will stay in 2, 2 itself, and what does the agent do is, the agent will take the next step, that is moving forward, making this as a visited, making 2, 2 as a visited. The agent will move from 2, 2 to 3, 2. If the agent moves from 2, 2 to 3, 2, there is a gold inside 3, 2, and there is also a stinch mill. So, but what is our goal here? The goal of the agent is to collect the gold and return back to its original position. So what? See, the agent, he is moving from 1, 1, 2, 1, 2, 2, 3, 2, he is moving till here, and he is collecting the gold and getting reverse back to 1, 1. So what is the safest path from this problem is, the safest path is 1, 1, grid 1, 1, then 2, 1, 2, 2 and 3, 2, right. So the safest path is to collect the gold and get back to its original position. So this all comes under what? Wumpus world problem. So to find the agent, with the help of the knowledge base, he has to predict and he has to get the gold and reverse it back. So so here we can use all three. Any problem we have to use the PEAS description, and you have to write what are the performance measure, environment, actuators and sensor. Okay, so this is Wumpus world problem with PEAS description. So here this is the inference engine. So in inference engine is a component. It is a component in artificial intelligence which uses the intelligence system. And what does the inference engine does it will collect the logical rules. It will apply the logical rules through knowledge base, to the knowledge base what we are getting. So the inference engine is a component which is used in artificial intelligence, and it will apply the logical rules on the knowledge base, and by applying the logical rules on knowledge base, we will get a new fact, and which can be used in the further explanation, right. So here the inference rules will be, we will get the inference rule from the knowledge base, right. We will collect this and we will give for the user interfaces. So this is the inference engine. So in the inference engine, there is a possibility of two modes. There is a possibility of two modes of inference engine. One is forward chaining. The next one is backward chaining. So So in forward chaining, the path to reach the goal is from initial state to the final state. So the path to reach the goal is from forwarding, that is from initial to the goal state, from initial to goal state, right. So the search will take place from bottom to top. The search will take place from bottom to top, and the approach what we use in forward chaining is data driven approach. So the data will be collected and it will be put into the database, the data driven approach. Okay. Next is backward chaining. Backward chaining is the reverse of its forward chaining. So the search takes place from the goal state to the initial stage. The searching will get the result, we will come from the goal state to initial state, and from top to bottom. The trace will take from top to bottom, and the approach what we are using is where we are starting from, the goal we are starting. So it is a goal driven approach. It is a goal driven approach. So here for the inference engine we have two modes. Commonly we have two modes we use here is forward chaining and backward chaining. So we will check how we are going to use, how we are transferring this rule into a knowledge base, and we are proving the theorem here. So here we have the rule 1 here. If A and C then F. If A and C then F, how we are going to convert this into a knowledge base? So how we are going to convert here is, there is a fact here. In the fact we have the A and B initially, A and B, and we are converting that rule into a knowledge base, that is A and B, A and C then F, A and C then F, then we have A and E, A and E then G, then B to E and G to D, right. So here we have to prove here, the proven theorem here is, if A and B is true, then D is true. That is A and B should be D. So this is the we have to prove. For the final there should be we have to reach the goal state as D here. So how we are going to reach the goal state here, and how we are going to insert the knowledge base, the characters whatever it is there inside, how we are going to insert into a fact here. So what we are going to do is, A and B here initially we have A and C, F, A and E, G, B to E and G to D. Okay. So here initially we are taking this B here. So what is B here in the knowledge base? B tends to E here. So what we are going to do, we are going to extract this. We are going to extract and put here A, B and E here. Extract this and put here inside. Okay, we have extracted this. Next what we are going to do is, we are going to again extract what? A, B, E, we are here now. We are going to extract what? E. What is E here? A and E is here itself. So A and E tends to what? G here. So we are going to extract again what? With the help of this statement we are going to extract the statement G. So here we are going to extract G here. A, B, E and G. G has come inside. So G has come inside and we are going to extract what? G. So where is G here in the statement? G tends to D. So extract D here. From this statement we are going to extract D here. So A, B, E, G and D. Finally we got the answer what? As D. D, we have got the answer D, and the D is into the fact. So finally, to get inside the KB knowledge, we are going to insert the fact of B2. The fact of the knowledge what we are going, already we have, we are going to incur into the database by extracting the statement, and we are going to put it into the fact. So we have finally reached the goal D. So we got the statement A and B is true, then D is also true. So this statement is, we have reached the goal state here. So this all comes under the inference rule. So here, as the forward chaining, we said that it is a data driven approach. We are going to extract the data and we are going to put it to the fact and knowledge, right? So this is forward chaining.